Let's look at another example computing a t-interval. This time we have actual data. So we have a random selection of 10 students, and we surveyed their average nightly sleep times. We got 7.1, 6.2, etc. down to 5.3. So 10 data values there. So part A, they want us to find a point estimate for the population mean sleep time. So, well, the population mean sleep time should be approximately equal to the sample mean. And the sample mean we can get from finding the mean in the calculator. So let's do that. So we want to go to Stat and then Edit and enter our list of values in. So 7.1, 6.2, 5.5, and 7.2, and then 6, 6.5, 7.4, a 6.7, 6.9, and 5.3. So there's our data, and now we want to go to Stat, arrow to the right to Calc, and we want one variable stats. Press Enter. Come down to Calculate, and we've got our sample mean, 6.48. There's our point estimate. Part B, find a 95% confidence interval. If we know that the population is approximately normal. So that's just going to allow us to satisfy the conditions for confidence interval. So here's our formula for confidence interval. And let's write down what we know here. So we know that our sample mean is 6.48. And if we go back to one variable stats again, we see that our sample standard deviation right there, 0.7177. So S is equal to 0.718. And then we are doing a 95% confidence interval, so alpha is 0.05. And that is the information that we have. We have 10 elements in our sample here, 2, 4, 6, 8, 10, so n is equal to 10. So first of all, we need that t-value, t alpha over 2. So our alpha is 0.05, so alpha over 2 is 0.025. So then that t-value with 0.025 to the right means 0.975 to the left. So this will be inverse t, 0.975. And then remember, you use degrees of freedom, which are 1 less than the sample size, so 9. So now we're going to second variables. We want inverse t, which is 4. And our area is 0.975. And our degrees of freedom are 9. 2.262. So let's now find our margin of error right here. And then we'll add and subtract it from the mean. So that margin of error is going to be our t-value, 2.262, times sample standard deviation, 0.718, divide by square root of the sample size, root 10. So I'll compute that on the calculator. So we have 2.262 times 0.718 divide by square root 10. So 0.51. Let's use 2 decimal places. We've got 2 in our mean. So 0.51. So now we add and subtract that margin of error to our sample mean. So our lower bound is going to be sample mean minus the margin of error. So that is our 6.48 minus 0.51. So 5.97. And then the upper bound will be our sample mean plus the margin of error. So take our 6.48 and add the 0.51. And that gives us 6.99. So our interval is 5.97 to 6.99. And then if we interpret that interval, this is a 95% confidence interval. So we are 95% confident that the population mean sleep time is between 5.97 and 6.99 hours. So that means if we took repeated samples of size 10, that 99% of those samples would contain the true population mean. This is one of those samples. So part C, is it possible that the students get the recommended 7 hours of sleep per night? Well, anything's possible, but it's not likely. Here's a picture of what's going on. This is your sleep time, and 7 hours is right here. And then the 99% confidence interval, that goes from 5.97 to 6.99. So that interval, which is centered at 6.48 right here, goes from 5.97 up to 6.99. It's just shy of that 7 hours. So this is our 99% confidence interval. And this is out of 100 intervals, 99 should contain the true population mean. This is one of those intervals. And we see that it does not contain 7. So it's highly unlikely, it's only a 1% chance that 7 is the true population mean. So it's not likely, since the whole 99% confidence interval, CI, is below 7. And 99%, move this guy up, 99% of confidence intervals generated from repeated samples contain mu, the actual population mean hours of sleep. So if 7 was in that interval, then that would agree with the possibility of having 7 hours of sleep per night. But since 7's outside the interval, that's only going to happen 1% of the time. So this is how confidence intervals can let us make an inference or draw a conclusion.